So remember, as I have numbers that are a little bit inconvenient, they're not small anymore, I have to slowly drift away from this intuitive understanding of, in this case, fraction calculations, right? Keeping things as basic as I can only works when the numbers are convenient enough for me to draw stuff. If I have unpleasant fractions like, I don't know, 17 over 53, who on earth wants to draw a rectangle anymore? No, I have to drift over here and see, well, my initial understanding, I just have division examples right now, my initial understanding of the arithmetic involved and the process on a basic intuitive level, can that lead me to discover properties that are true in general? Now, as a teacher, I'm using inductive reasoning, and of course, I know the risks, but we can still use these examples to spark that thought like, oh, there has to be a faster way to do this. I'm eventually, as little Timmy, going to get sick of drawing these rectangles, especially when the numbers are a little bit less convenient. Surely there's another way. And that's totally fine to ask that question and to want to be more efficient, but it should happen after this. So because we have the time, let's just go through and see, because it's not necessarily obvious for everyone and for each of the operations, how we can use this basic approach to suggest how to handle the less convenient numbers. Now, in the case of addition and subtraction, let's just take something small, right? Let's just take a quarter plus, I'll start with a plus, let's say 2/3. Actually, sure. Now, I know what to do here. I start with my first number. That's what I have. So I'll do a quick version here. I have to represent it, of course. I don't want to make a mess of it, so I do want to use straight lines. But we've done it a few times now, so we can do it really fast. So I have some stuff. According to the first fraction, I don't need to make these big to understand what's happening here. Then I'm going to put that together with, oh, no, not pink. Together with, because I'm adding, can I write? Another rectangle, some more stuff. Now, if I prepared better, we would have had this already visible, but I did not. Now let's make them as effective as possible and go horizontal here, like we updated it. And I know that I'm going to have some of this already, 2 rows in this case. Now the question was, I'm not going to write out everything, so let me just make it clear here. This is not the full presentation for this kind of question, like in a test. This is just what would we have, and how, excuse me, how does that lead me to the eventual shortcut when I need it, when numbers get more complicated. I can lead students to that discovery, even at this basic level. So what do we have? So at that stage, we want to be able to put these together. The sizes are not comparable, so we have to split them up in the opposite way. Oops, I'm blue, don't be blue. And this way. And here really is the thing. As soon as we do that, what have we done? What have we done? when we use the other denominator and split it up in the first rectangle. For the second rectangle, use the other denominator and split it up in the other direction. Now we've created 12 pieces. By doing this, we've created a common denominator by making them comparable. And it's always going to be 4 times 3, the product of the two denominators. Because I had 4 pieces originally, split that one into 3 pieces, that's exactly multiplication. How many pieces do I have? In the second one, I did the same thing, just the other way around. So the result's going to be the same. So what I've actually done here is converted this 1/4 to an equivalent fraction 3/12. This 2/3 to an equivalent fraction 8/12. And even though on the intuitive level I then did an integer addition, I just dropped the 12 and said 8 plus 3. So what we really did here was the shortcut just in visual form. We just didn't write it over a common denominator because visually it was done for us. Then we said 3 plus 8 is 11. How many pieces does it take to make a whole rectangle? 12. Therefore, our answer is 11/12. Now I will stress again, it is on record, on video. I will quote this video if you say anything later on. This is not how you answer the test question. This is now when you're teaching and Timmy is ready to move on, drift towards more efficient methods. I'm showing how our basic rectangular method, there's sentences here, there's stuff happening, like always. That leads me to notice what we're really doing without the diagrams. If the numbers are more or bigger, less convenient, and I can't draw rectangles anymore, I can still imagine doing this. We're just not going to draw them. And then this is what we actually have. So behind the scenes, there is the suggestion of the shortcut, the more efficient methods that we can lead the student to with enough and appropriately chosen examples. Now the subtraction is going to be very similar. I don't even know if I need to do it. Let's just say we had them backwards because we have more blue than pink, right? So we can't subtract this one on the easy way. No negative fractions here. Then in the subtraction case, we did exactly the same thing. We might not have seen the second one, but we still had to create columns according to one denominator, rows according to the other, and as soon as we did that, we've created a common denominator. That common denominator is always going to be the product of the two denominators. And with enough examples, Timmy might see that, but wait a minute. It's always going to be the product. Why do I need to keep drawing rectangles? That means he's ready to move on to take a step to better understanding and more efficient methods. But he has to make that choice. We can't choose for him. He has to start with a number sense and then build on that. So in the case of subtraction, it's very similar. The method was almost the same. I just didn't show the second quantity because I had to remove it from the first. And when I then do the removal, it's just a minus here and everything is pretty much the same. Let me see a multiplication example. I don't have one written out, unfortunately. So we'll quickly have to do one to see what it looks like again. And when I get to these bigger ones, let's say 2/3 times, it doesn't even matter, does it? 1/4. Make it nice and simple. I have the first quantity. No, sorry, the second one I mean. Sorry, thinking of division. So let's represent that. And because it's 1 over 4, I need to split it up into 4. All right. Then let's color in what we have. We have 1. It's not nothing, but it's not much. So then our instructions are to get or take, or we get, to keep, whatever words you want to make it distinguishable from the others. Use different keywords, good idea. 2 of 3 rows. I can't use columns because I've used columns already. So rows is the obvious choice. And for that reason, I need to see 3 rows. Now, what have I done? As soon as I did this, what did I really do to the fractions? I again created a common denominator, or in this case, I don't want to call it a common denominator. I have created the product of the 2 denominators. Product of the 2 denominators. And that's why my answer is going to be over 12, because looking at this rectangle, it's going to eventually be a sentence. It takes 12 pieces to make a rectangle. That's going to be a sentence over here. And that's going to lead me to my answer with a denominator of 12. Because of what I do in this intuitive process. Now, how do I get the numerator? Well, we get to keep 2 of the 3 rows. So we said yes, yes, no. So now, if this was maybe bigger, I would have more pink. Whatever this numerator is for the second number, the number that I have, the pink one, I would have that many columns, right? 1, and I have 1 column. 2, and I would have 2 columns. 3, and I would have 3 columns. I then take this many rows, which means I multiply the number of columns by 2 in this case. It's going to be the product of these 2. So let me actually backtrack here. I should have been more clear. It's 3 times 4. And it's always going to be the product of the 2 denominators, my new denominator. And because of what I do in my basic method, it's always going to be the product of the 2 numerators. Now, maybe a couple more examples to convince little Timmy, because as I go from addition, subtraction, multiplication, and to division, they do get a little bit more complicated, maybe a touch less intuitive. So observing the pattern might need more examples until little Timmy is convinced. That's my goal. Because I know that this is true. I just want to lead him with inductive reasoning to that, which I know is a safe conclusion. Now, if you aren't completely happy with why is it the product, you have to be able to explain. Why is it the product of the top 2? Why do I multiply the top, multiply the bottom? Why? Just because I'm used to it and I've stopped thinking about it, that's not a reason that makes it true. I can use my intuitive basic introduction method to multiply fractions to justify how these 2 numerators and these 2 denominators are put together to be able to find the answer without a diagram. So when the numbers get a little bit complicated, I'm able to step away from this and still find the answer. It's not the first step. It's not what we're going to do in a test, but there is a connection. These aren't detached, that when I want to get them to handle larger fractions, I just have to give them the formula and have them memorize it. No, I can justify it from their current understanding, from their fraction sense. We can discover this property, and that will mean way more. There is no blind memorization. There is just understanding. But some variety here to get them to see the pattern. Oh, it's always the top multiplied together. It's always the bottom. Oh, that discovery means way, way more. And then luckily we have some division, right? Let me just think, is this the best example? Don't want to work with that one. I don't like any of these examples. Yesterday's example was a good one. So let's make another one. Division is arguably a little bit, is the trickiest one to defend like this. Let me just pick it backwards. Of course, if I have mixed numbers now, we run into the issue that when we want to be more efficient, we have to make improper fractions and stuff like that. That's a continuation, another step after this. So let me just set that up. We have 7 minutes. Why not? To see how this one feels. So I'm going to go thirds vertically. This one can be a little tricky to keep track of. So I want the first time I want the numbers to be decent. Hopefully this one could be. I have 2 of them, right? We want our first example to not be big or weird, but comfortable fractions. Okay, so then we said, like we've done 4 times now, our group size is going to come from a quarter of a whole. That's going to mean, whoops, not 2, but 1 of 4. It's going to have to be rows. Now, just because I am going to make 4 rows doesn't necessarily mean the same as it did previously. Because we're not going to do the same thing. Yeah, I do need to see the rows so that I can see my group size. Group size is 3 pieces. Okay, 3 pieces. All right. 1 of the 4 rows in a whole rectangle, 3 pieces. So now I need to fit it in. Now we're going to write the full sentences. We're just trying to, I just didn't have a nice example for my first attempt here. Fit in my group into what I have. Let's see it. Let's make it blue. Make it blue. There's 1. There's maybe another one. 2. And I have some left over. So I can fit it in 2 whole times. Let me just think. Yeah. 2 whole times with 2 left over. I have a lot of 2's floating around here. That might not be ideal. Or we could say, excuse me, how many pink do we actually have? We have 1, 2, 3, 4, 5, 6, 7, 8. Let me write the have here. Have 8 pieces here, pink. And I'm trying to fit in groups of 3. So let's just maybe see the integer calculation. It's going to be 2 with a remainder of 2 as well. So I know my answer. I know my answer is going to be, I'm just going to put it up here, in the corner here. My answer is going to be 2 whole times, excuse me. Get all choked up about division. 2 whole times I can fit it in with 2 of the 3 that I need. left over. Now, in the case of division here, even the nice small fractions, the mixed number doesn't immediately show how to get these. I'll do the improper fraction, which is 8 over 3. And that then shows a little better where the behind the scenes calculation actually where it sits. The mixed number is very much a presentation thing. As soon as I step just a little bit away from the left intuitive side, mixed numbers really have no place. They're not efficient or clear in any way. They're a presentation thing that I use at the very beginning and then honestly never again. Whenever I want to do any calculation with any sort of efficiency, it's going to be improper fractions. But these are behind the scenes. I might not say it the very first time to little Timmy, because he's not ready for it at that stage. But the 8 and the 3 are behind the scenes, right? It is 8 that I have, 3 that I fit in. How many times can I do that? So these are equivalent, of course. Now the question is, of course, we only have one example. When we now think about this, you need a couple to have them see the pattern. So then the question is, where does the 8 and where does the 3 come from? Well, the 8 first. I had 2 columns of pink stuff. 2 columns of pink stuff. That is the numerator of the first fraction. 2 columns of pink stuff. I then split it sideways according to the second denominator, 4. And I've created 8 pink pieces. So it's going to be those 2 multiplied together. One from the top, the first one, and the bottom one from the second fraction. That is my new numerator in my answer. And it's always going to be. Then, the group size. The group size. Well, I originally split it up in columns according to the first denominator. Regardless of what I have, it was 3 columns, my whole rectangle. Then I take a number of rows according to the numerator of the second fraction. And that if I had taken 2 rows of the 4, if that was a 2 and not a 1, I would have 6. 2 times 3. So those 2 get multiplied together. The 1 is a little inconvenient. It doesn't seem like actually anything has changed, but it has. And that's the denominator of my answer. Now, of course, division is more complicated. It'll take more examples to see the pattern here. Now, because I'm multiplying stuff, it's just a little up and down, little diagonal here. You can hopefully see that this is very close to multiplication. That I would get the same result if I just flip the second fraction and then do my multiplication straight across, which corresponds to fraction multiplication. I would get exactly the same thing. And do a few examples. Verify inductively that this is always going to work. Of course, it's not a proof, but we know it works. We're just trying to lead them to that discovery. So there's a lot of connections here that can be discovered by way of my rectangle method, by way of my number sense that I've built. And then when things get more complicated, I'm ready as little Timmy. I'm ready to let go of the drawing and trust my discovery and just take that further. But it has to be an organic, natural process, or it won't give me confidence. If I compare being told something that I have to memorize and use it, yeah, I'll get used to it, I guess, because repetition does amazing things. But if I discover something myself And for a moment, at least, I'm going to think, I've realized something that no one else has. Look at this. Look at these connections. I could just use this and match them up and get the answer. Does anyone know about this? I don't have to draw any rectangles. This is amazing. And if I flip it, it's the same as multiplication. My mind is blown. For a moment, at least, you think you're the only one discovering it. That is going to mean so much more, and I'm going to remember these things so much better moving forward by having a more natural process of discovery. But it's up to the teacher to guide me to that. Instead, teachers just give them formulas to memorize because the teacher themselves, they don't understand anything. That doesn't make it right. That makes a bad teacher. We want to be better than that. And all these things are connected in so many ways. There's so much more we can do here. And build confidence. Remove all anxiety. There's nothing difficult about fractions if I take the right journey and the right approach. But I'll stop my rant there. Are there any last questions? Any last questions before we wrap up this fraction arithmetic portion?
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.